नमस्कार दोस्तों, वीएनपी नेटवर्किंग ट्यूटोरियल्स में आपका स्वागत है। Today we are going to perform a lab for iBGP. So for this I am using the simulator GNS3. You can use a simulator of your choice such as UNetLab or EVE-NG. But for this I will be using GNS3. It's a very simple and straightforward simulator to perform any labs. So let's begin. So I will be taking two routers here, router 1 and router 2. So let's connect their interfaces. So on R1 I will be using fast Ethernet 0/0 and R2 I will be using the same interface, fast Ethernet 0/0. So let's assign the IPs to this interface on this topology first. I can use the text. So the subnet between R1 and R2 I'm using is 10.1.1.0/30. On R1 the IP will be .1 and on R2 the IP will be .2. With /30 mask you get only two IPs. So I will also be creating a loopback behind router R1 and R2. The loopback IP will be 1.1.1.1/32 for R1 and for R2 it will be 2.2.2.2/32. So as I said that we are doing iBGP, so let me just take both the routers inside this oval shape diagram so that it will very easy to understand what is the AS number we are configuring. So I will consider it as AS number 10. Means what? R1 is having AS number 10, R2 is having AS number 10. Both are in AS number 10. So the BGP we are doing here is iBGP. So the task is to form iBGP between R1 and R2 routers. R1 having interface IP 10.1.1.1/30. R2 is having 10.1.1.2/30. The AS number for these routers is 10. That means we have to configure the iBGP. So let me start these routers. Okay. Right click R1, take console of R1. Okay, I have the console of R1. I can configure the interface IP for R1. The first is enter to the global configuration mode through config T. Enter the interface configuration mode. Our interface for R1 is fast Ethernet 0/0. Assign the IP. The IP is 10.1.1.1. The mask is /30. /30 means 255.255.255.252. By default, the interfaces are disabled. You can make it enabled by making a no shut command and exit out of the interface mode. So R1 I have configured the interface IP. I need to configure the loopback as well. So the command is interface loopback. How many loopback you can configure? It's a very large number. So I will take loopback number 1. I will assign the IP 1.1.1.1. Mask is 255.255.255.255. So loopback is a logical IP. It remains up irrespective of the physical interface. So I will exit from the interface mode. I can save the configuration through do write command. Since I'm in the global configuration mode, I will use the do command. Now let's configure R2. Okay, let me adjust the window and I will configure the IP for R2. So I will enter the global configuration mode. Now the interface fast Ethernet 0/0 for R2, IP address 10.1.1.2, 255.255.255.252. No shutdown to make the interface enable. Exit from the interface configuration mode. Now enter the loopback interface. Interface loopback. I will make interface loopback 1. Assign the IP 2.2.2.2. Assign the mask and save it. Do write, save it. Okay, so let's see if our IPs assigned are correct or not. Show IP interface brief. Okay, so for R1, I think it's for R2. Yeah. So the R2, we have the IP fast Ethernet 0/0 IP is 10.1.1.2 as expected. Yes, 10.1.1.2. We have the loopback configured 2.2.2.2. Both are up. Let's check for R1 as well. Same command you can use. Show. Let me just modify, increase the window size. Show IP interface brief. Yes. So we have the correct IP as expected. Interface fast Ethernet 0/0 is having 10.1.1.1 and with a loopback IP 1.1.1.1. Okay. So the IP configuration is done for both the routers. Now let's see if BGP is enabled or not here. So show IP BGP. If you see, it's showing as BGP not active. Means you have not configured the BGP. Let's check for R2 as well. Show IP BGP. BGP is not active on R2 as well. That's what it's showing as BGP not active. Means BGP is not configured. Okay, fine. So we will start the BGP configuration part. Let me little adjust this. Okay. Okay, so we will configure the BGP on R1 first. But meantime, I would like to start the Wireshark captures on interface R1 because we need to analyze the Wireshark capture. What are the BGP messages that get exchanged? So let me right click on the R1 site and there should be an option to capture. One moment, let me put this. Let me right click and yeah, there is an option to start capturing. Yes. On R1 interface fast Ethernet 0/0, I will start the capturing part. See, till now I have not configured the BGP. So I want to capture all the packets that initiate through the BGP. Start Wireshark. So this will allow us to capture each and every packet that is used for BGP formation, and we can analyze them in great detail. Okay, so I will start the BGP configuration port. It's very simple and straightforward. Go to global configuration mode. You can use the command router BGP and you need to provide the AS number. So we are forming the iBGP session with R2. So it's asking for the AS number. So in case of iBGP, since we are doing the iBGP, so AS number for both R1 and R2, it will be the same. So for R1, the AS number is 10. So router BGP AS number 10. Now you have to provide the neighbor command because it will ask for the neighbor with which you want to form the iBGP neighborship. So neighbor is 10.1.1.2 and remote AS command means with which, what is the remote peer with which you are trying to form the BGP neighbor. So remote is R2 and the AS number for R2 is same since we are using the iBGP. If you see this, we are using the iBGP. So any routers within the R1 and R2, they will have the same AS number. Okay. And I will also advertise the loopback 1.1.1.1 on R1 so that once the BGP is formed, it will be exchanged, then the loopback information will be exchanged to R2. And we have to provide the mask command. Okay, and I will save it. Now we have done the BGP configuration only on R1 side, not on the R2 side. So let me do the same on the R2. On the R2 also, I will start the BGP configuration. So very simple. First enter the global configuration mode. Router BGP. Your own AS number is 10. Neighbor command. What is the neighbor for R2? It's 10.1.1.1 because we are forming the neighbor with the directly connected subnet. So R1 is having IP 10.1.1.1 and the remote AS from R2 perspective is R1. So AS number is 10. R1 is using AS number 10, R2 is using AS number 10. So it should be iBGP. And I want to advertise the local network. What is the local network? See, before we advertise, you might see a message, a pop-up message that the BGP adjacency or the BGP neighborship is up with R1. Okay, so let me advertise the network, local network on R2 with mask. Whatever the mask is configured, you need to mention that. And save it. Okay, now how can I validate? Very important. Okay, what command I can use? See here also on R1, there is a pop-up message that BGP adjacency with neighbor 10.1.1.2 is up. But there are some show commands which we will use. So the command is show IP BGP summary. Okay, there are so much information in this. So let's start. What does exactly mean? Show IP BGP summary. If you see on R1, BGP router ID is 1.1.1.1 because that is a loopback. So loopback is preferred over the physical interface IP. So this is the router ID, a BGP router ID for R1, and the local AS number is 10. Okay. If you see at this this highlighted section, okay, it will show you neighbor. Who is the neighbor? Neighbor is 10.1.1.2, which is R2 router. Okay, and we are using the remote AS. The remote AS is 10. Message received, message sent. 4 messages are sent, 4 messages are received. The very important thing here is if you see this up and down, so it shows that 56 seconds the BGP is up and you have received one prefix from the neighbor 10.1.1.2. Okay, so this command shows that you have on R1 you have this neighbor 10.1.1.2 and the BGP is up since last 56 seconds and you have received one prefix. If you execute this command once again, show IP BGP summary, you will see that this time has changed now. This time has changed now, and this will definitely increase continuously. Okay, and you have received one prefix. Now let's see on the R2 side. So on the R2 also you can execute the command show IP BGP summary, and it will list out, the first thing is the router ID, the BGP router ID, which is 2.2.2.2 for R2, and the local AS number is 10. If you also see the neighbor 10.1.1.1, it's the R1 neighbor for R2, and the uptime is more than 3 minutes with a one prefix received. So in the next lecture, we will try to analyze the packet captures which we did on the Wireshark, and we will try to understand what is BGP three-way handshake and what are the different packets that got exchanged while BGP formation. So please also view my next video for the same, and thank you for your time.